Hello friends, very good evening and welcome to the one of the very important topics of lean, the value stream mapping. As you most of you must be aware about the value stream mapping. It is like suppose we want to improve our health, the very first thing we must know from where to begin. Because for the improvement, we have to identify what are the problem points or deficiency in our health that has to be detected first, then each one has to be improved step by step. The same way for any organization, if they want to improve their processes, they have to first diagnose where are the problems in the processes that must be resolved, then only improvement can take place. The same way, the value stream mapping is a health diagnosis of any manufacturing or any service process. This is equally applicable to manufacturing and services both. In fact, personally, I believe this is the most powerful tool and the foremost activity for any improvement journey. So, as I told, this is a diagnostic tool to identify the problems hidden in your system which are not visible, but they must be resolved for the performance of the process. Let's start. So before coming to the contents of it, let's have a quick outline of the this webinar. As it is mentioned, it's a problem detection approach through the value stream mapping. What we are going to discuss is first we must be clear what is the goal of the organization. Then what prevents achieving the goal. The value stream mapping is one of the diagnostic tools which identifies the problems hidden in the system. Then how to conduct value stream mapping. There, after the value stream mapping, the first we have to make a current state value stream map. It is a snapshot of the current way of operations. Then that snapshot of the current state value stream map is analyzed to know where are the problems which is causing waste, and based on that analysis a future state design is made. That's called a future state value stream map, and then the gap between the current and future state value stream map, which has to be bridged through the various problem solving improvement projects. That's why the value stream improvement plan is made. That is the main outcome of value stream mapping activity. Then the next phase after the plan is made, that is implemented through a problem solving technique. One of the very famous problem solving technique used by the Toyota, which whole world is trying to learn, called A3 problem solving. So I'll be discussing on the A3 problem solving on the 15th of February in continuation of this series of the webinars, because the value stream mapping and problem solving are complementing a step. Just like in healthcare, doctors use two-step journey. One is the diagnostic journey, and second is remedial journey. The same way, value stream mapping is a diagnostic tool, and A3 problem solving is remedial tool. So both are planned together. So earlier also we have discussed, first there should be very clear understanding of the goal of the organization. The starting point for any activity is we must know what is the goal. From the lean approach, we call the goal is growth, where the profit is one of the subsets of the growth. Just we are making some adjustment in the system. Please bear with us.
Okay. चलो
इसको फुल पे कर दो, इसमें मोड पे चलता है
नहीं चल रहा है
नहीं इसमें
अच्छा हाँ क्लिक कीजिए ना ठीक है
Yeah. Okay, friends. The goal of the organization is the growth, where the profit is one of the subset. So now we have to find out, Miss, what prevents the growth of any organization. That is the problems. There are several problems, visible and invisible. Most of them are invisible. They are preventing us not to make comprehensive growth of the organization. So unless these problems are identified and resolved, there cannot be growth of the organization. So how to make growth happen? As I mentioned, two-step journey. Basically, first we have to identify the problems and then solving those problems. So these are the two tools which we'll be discussing. Today is the value stream mapping is the tool for identifying the problem, and A3 problem solving we'll be discussing on the 15th of February as a remedial journey to make processes robust. So what are the challenges for every small, medium enterprise or the emerging corporate accounts? In fact, for all the companies, first, to increase the sales, and second is increase the profitability. So the sales revenue, what we call as top line, has to be also increased, and at the same time, bottom line, the profitability has to be also improved. These are the two basic targets for every business organization. How to increase the sales and profit together? So to increase the sales or the market share, we need to have a global competitiveness. Today we are competing not just only domestic competitors, but the global competitors. In every area, you will find the competition with China, Taiwan, Korea, or several other countries. So the global competitiveness, that is the key for increasing the sales volume. At the same time, we have to reduce the cost to increase the profit margin. So now what makes our products less competitive and more costlier? From the lean, it is very clear that there are several kinds of waste which are generated in our processes. They are reducing competitiveness and profitability of every kind of organization, whether it is manufacturing any product or providing service to the customers. But waste are just symptoms. Just like suppose we are facing the fever. We are suffering from the fever. Fever is a symptom. It's not a disease. It is not the fever is happening because of certain hidden problems. It may be infection, it may be stress, or it may be any other physiological, biological problems. So the waste are visible, but behind the in substratum of the waste, there are some problems hidden. So solution has to be evolved for the problems. So before going for the problem detection, let's see how the waste is generated. From the lean perspective, every organization is a network of interdependent processes. All processes are, as you see in this diagram, network diagram, purchase, design, production, maintenance, quality, services, shipping, and there are so many other several kinds of processes. Those are interconnected. All are interdependent. So, but in each process in the manufacturing, we have all studied that 4Ms are the basic inputs that is used in all manufacturing process, whether the company is small, large, or medium enterprise. These 4Ms are materials, machines, manpower, and methods. So, in a production black box, the four kinds of operations are performed. These are the retention. Whatever the material comes, we store it for some time in a company store or in between some process. Then the material is transferred to the relevant process where the processing is done. And finally, after the processing, the outcome of the process or the product is inspected. And if it is okay, then it is dispatched. So these are the four basic operations performed in every process. These are the retention, transportation, processing, and inspection. In these four operations, at any moment we are doing two kinds of activity, which is called as value added activity and non-value added activity. Value added activities, they develop value what customer wants, and the non-value added activities, they generate waste which neither customer wants nor supplier wants, but undesirably these are being generated. The main problem is the waste, and this concept was evolved by Toyota, and the Toyota production system focused only on waste elimination, detection and elimination of waste using these two tools. And today it is recognized, globally recognized as the most effective and efficient production system, and the whole world is trying to learn it. So any process is generating two types of outputs, the value and the waste. So the value is defined as the inherent worth of a product or service as judged by customer and reflected in its selling price and market demand. So today, every company is supposed to provide value to the customer. To understand value, the simple way, there are three most important elements of the value are the quality, cost, and delivery. All the customers, even in the past, they wanted quality, cost, and delivery. Today, they are looking for the best QCD combination, and in the future also. So the whole purpose is to improve the quality, cost, and delivery to make your product competitive and sellable with the highest profit. So all the effort has to be made to improve the process so that they can produce and deliver the best combination of QCD. And what is a waste? Waste is defined as any business activity that absorbs resources but does not add value. All resources they are procured at a cost. So any waste, whatever is being generated, it is resulting to increase in the cost. So anything more than minimum requirement of material, space, energy, equipment, time, effort, or any other resource is a waste. This has to be detected and eliminated. So as I mentioned earlier, waste is a symptom. We can see the waste, but problem behind or at the bottom of waste is not visible. That is a problem. So these are the 8 kinds of waste classified by the Toyota, and they focused on detection and elimination of these wastes. First is the overproduction waste. It means producing without order. Then second is the inventory waste. Anything more than the required, whether it is a raw material or the WIP or the finished product, is the waste that is adding cost. Then defects, all of you know, any defect has to be defective item either has to be reworked to make it right, or if it cannot be reworked, then it has to be scrapped. In both the cases, you have to spend money, and that is reduced from our profit margins. The fourth one is the waiting waste. Many times you find that in any process out of the 3, the man, material and machines, sometimes material and machine is ready but the operator is missing. Sometimes operator is there, material is there, the machine is waiting because of the repair. And another situation where the machine and operator are ready but the material is shortage. So the waiting is one of the major ways that reduces the productivity and profitability. The fifth is over processing. It means for production of any item, if extra steps are involved, unnecessary extra steps are involved, which can be avoided by improving the process methodology. So that's called over processing. In many, just like in, for example, for the release of a check, there are so many steps are involved, so many people approve, then it is finally the check is signed and issued. The same way for production of any item, there may be extra steps which can be eliminated by improving the process. So that is another waste. And the sixth is motion waste, where the human energy is wasted because of the unnecessary bending, stretching, moving operations. The seventh is transportation. Because of the layout problems, many situations the material has to travel more distance than required. And finally, unused talent of the people. People are having a lot of experience, but that experience is not used because they are not getting any opportunity for applying those, and these opportunities can be provided for solving the process problems. So these are the 8 kinds of waste. They are the main reason for any company to make less profit, to become less competitive. So now the challenge comes how to reduce cost and improve competitiveness. For success of any organization, these are the 3 essential steps. They have to reduce cost, they have to improve the competitiveness. So this is 3 steps are used, 3 phases are improvement journey. First, detection of waste, the second, elimination of waste, and third step is the prevention of waste. So For the detection, elimination, and prevention, there are different kinds of tools are required, just like doctors they do. For the detection, different kind of tools and laboratory is required. Elimination or the remedial journey, different approaches required. You need uh, medicines, you need actions to eliminate that cause of the waste, and finally preventive is to ensure that it is the waste after improvement journey doesn't reoccur for the preventive steps. So these are the three essential steps. So the value stream mapping is the most effective tool for detection of waste. So how to detect the problems hidden in your process is just go for the value stream mapping. First, we have to understand the value stream mapping. What's value stream? It is all of the activities required to fulfill a customer request from order to delivery. Like the traditional organizations are organized in the vertical silos or departments, just like purchase, production, quality assurance, shipping, dispatch, all these. But in the value stream mapping, all these are the vertical organizations are reorganized into horizontal process. In any value stream, there is all the activities, purchasing, production, QA, packing, shipping, all are involved. So vertically, we have to see that right from the customer request to the customer receipt of material, all the processes has to be mapped horizontally, and we try to find out which is causing waste and delay. So the value stream mapping generates value stream map. So it is a simple tool that visually represents what's going on in a value stream. It is just like a snapshot of your operations, exactly what is being done at this stage. So the value stream map that provides complete view of operations. So for making the value stream map, we have to understand some key lean metrics which are used. There are so many metrics are here, but I just discuss some key metrics you must understand. The first is the takt time. It is called as demand rate. Takt is a German word that is just means a drum beat, means giving indication next. So what is a demand rate, customer demand rate? That is a takt time. Then comes the cycle time. The, what is your production rate? Means in fact the lean, the whole purpose is your production rate should be equal to the your demand rate. Once these two are the balance, there won't be any inventory or the wastage are minimized. So the cycle time and takt time must be synchronized. Then the third is the changeover time. Because of the change of one product to another, several times we had to stop the machine and change the dies, tools. So that is a changeover time. The next is the uptime. Actually, what is the actual operating time of any equipment? That is important. That has to be measured. Then the first pass yield. This is one of the very powerful quality metrics that indicates in the very first go what is the yield, how perfect is your process. Then the next is the inventory turnover. That shows how fast you are rotating your working capital to generate more sales. And finally, the lead time is right from the customer order to delivery, whatever the time is taken by the company, that has to be compressed. Because lead time is one of the very important parameter, because every customer they want the material immediately or in the minimum possible time. The approach of lean is to compress the lead time so that more output can be generated or more throughput is created from the company. At the same time, customer gets desired product or services at very fast speed. Let's try to understand the cycle time. It is how often a part or product actually is completed by a process as timed by observation. It is, as you are seeing in this particular diagram, it is the interval between delivery of two products, two units from the process line. That is a cycle time. This has to be measured. Then the changeover time, like in the most of the presses or the tools or the mills, you are changing the roles. So for changing the tools and dies and setting, the machine has to be stopped. So that is a changeover time. To have a higher productivity and lower cost, changeover time has to be minimized. Then the lead time, right from the beginning to end, from order to delivery, or how long the material stays in the process, that becomes the total lead time. Uptime, as I explained, this is related with health of equipment. Actual operating time divided by the available time. Actual operating time is calculated as available time minus changeover time plus breakdown time plus idle time. So to increase the actual operating time or the best utilization of machine, you have to reduce the changeover time, you have to reduce the breakdowns, you have to reduce the waiting time or the idle time of the machine. So after reducing this, what's available time is total available production time minus planned downtime. So here the example to calculate the uptime of any equipment. First example is given: if shift timing is 8 hours, any machine is supposed to run for 8 hours, then planned downtime 30 minutes per shift. For the machine checkup, changeover time is 40 minutes per shift, breakdown on average is 20 minutes per machine, and idle time due to no material or no operator is 10 minutes. Then the available time becomes just 30 minutes. Whatever the planned downtime, that has to be subtracted from the total available production time. Then the actual operating time is a 4, but because of all other unplanned and planned downtime, actual operation is only for 380 minutes instead of total available production time 450. So the uptime is 380 divided by the 450 minutes. So it becomes as 84.4%. This is the maintenance people are the supposed to increase the uptime. Maintenance and operation jointly, they have to increase the uptime to reduce the cost to have the higher productivity from the process. Next is the first pass in. This is very important to understand. If you are having a 4 operations in your company, you might be doing 95% in each step, but ultimately the total uptime is just multiply, it comes to so low. So here the total, it is called as a throughput yield also, that has to be maximized. So now those metrics what we have explained, that has to be used while the value stream mapping is being done. So what's value stream mapping? It is a follow a product's production path right from beginning to end and draw a visual representation of every process in the material and information flow. Then draw a future state map of how value stream flows, how value stream makes the material and information flow. So in any value stream, we are doing all kinds of activities, including value added and non-value added, required to bring the product from raw material to customer. The purpose is to measure exactly how much non-value added activities we are doing along with the value added. The whole objective is target is to minimize the non-value added activities so that more output is created from the same resources. So as I mentioned earlier, how you map it. if there are some problems, some waste will be generated. So as you see here, through the value stream mapping, we dig out, we go in the hidden part of a process, try to find out the problems which is resulting to the various kind of waste which are categorized in 8 categories as discussed earlier. So here the problem identification is the key purpose of the value stream map. This is a very structured methodology. It was developed by Toyota. They call it material and information flow diagram at the soft floor level, and that has been further improved by Lean Enterprise Institute and redesigned as a value stream mapping as a more comprehensive approach. So these are the steps in the value stream mapping. First, you have to define the product family. Say, for example, an automobile company is making large variety of products. Like it has to be classified into various product families. So for a auto company, for automobile component company, means we can call one is the passenger cars is one product family, truck is another product family, bus may be another product family. So because these are using similar kind of, each product family is using similar kind of processes to make it. So here each product family uses a typical value stream. So here the whole purpose is the value stream mapping. For the entire product family, a value stream has to be mapped to detect the problems in system, which is a resulting generation of 8 kinds of waste. So value stream mapping has to be done for each product family separately. Each value stream for one product family is selected, and then document the current state, the way it is operating as is state today. It is just like taking a snapshot through a camera of any operation. So current state operation is the actual snapshot of current state of processes. Once the snapshot or the current state value stream map is made, then the experts or the process managers, by learning the methodology of value stream mapping, they can just find out, analyze the process current state map, and they can find out where are the problems which are causing the waste. So the analysis helps to find out where are the problems hidden, and then what can be lean solutions for solving those problems, that is visualized by the experts, and based on that a future state map is made. After that shows, after the problems are solved, how a process would look like. So there is a gap between current state and the future state map, which has to be bridged through the improvement projects. So every problem identified in the value stream, that becomes project for the improvement, and those improvement projects are developed, are created as a value stream improvement plan. So the outcome of the value stream mapping is actually the value stream improvement plan. Just like doctors, they conduct several diagnostic studies, testing, and after analyzing all the test reports, they come out with a prescription. That is a prescription is nothing but an improvement plan. The same way in the value stream mapping, after collecting all data, it is analyzed and problems are identified. Based on that, then the improvement plan is created that becomes prescription or the blueprint for the improvement. That is the real outcome of value stream mapping exercise. And then the next phase, it is implemented through Kaizen projects using the problem solving techniques. So this is the structured methodology for detection and solving the problems. Let's take a very simple example of to understand the value stream mapping. Like in offices, every day we need to staple paper. Suppose there is some bulk stapling requirement is there, which has to be 100 copies of 3-4 sheets need to be stapled, so it becomes a process. So for stapling the bunch of papers, first an operator has to do pick up a paper, pick up the set of papers, then walk to a stapler, which is kept somewhere at a distance. Then third, staple the paper, and finally walk to desk where it has to be kept, and then put down the paper on the desk. So one operator, he is doing all these activities. How the value stream map is created: first all the 5 activities or the 5 processes are mapped, then time for each operation is recorded, and how much distance the person who is stapling the paper is traveling. So to pick up the paper, no transfer, no movement is there, but the stapler has been kept at some different place, so he has to travel 20 feet to pick up the stapler and then staple the papers, which requires 2 seconds, and finally walk to desk, which is another 20 feet away from the paper from where he has stapled the paper. It requires 5 seconds, and finally to put down the paper on a specific place, it requires another second. So if you just see, 2 things are important: where is the location of a stapler and where to place the stapled papers. So you just analyze total distance, total time required for stapling one set of paper is 14 seconds. Total distance traveled by the operator is 40 feet. So value added time, if you just see, just a 4 seconds. This walking to pick up the stapler and walking to desk to keep the paper is a non-value added time. Now this is generating transport waste, where the 40 feet distance has to be traveled by the operator, which is not adding any value. So this is mapping that discloses the weakness of the system. Now the same process, let's see, from applying the lean approach, how we can improve upon. Now we have to improve the process. All the 4 operations can be clubbed together on a single work disk. Now the pick up paper, pick up a stapler, staple the paper, and put down the stapled papers. Means all 4 operations can be organized at the same place. And let's see how much time it takes. 1 second for picking up the paper. Distance traveled is 0. Then picking stapler, 1 second. Distance traveled is 0. And staple paper, 1 second. Distance traveled is 0 feet. And finally put down paper, time 1 second. So distance traveled 0. So what has been done to improve this process, the layout of all 4 steps has been reorganized and all operations perform on the same workstation. So transportation waste is totally eliminated. Whereas in the earlier process, he has to travel 40 feet distance. So steps reduced, one step is reduced. So the 5 - 4 steps are required now and time saved. Earlier it was taking 14 seconds. Now, now it takes, whereas the value add time was only 4 seconds, just all the non-value added time has been reduced. And now the operation means there is 71% reduction in the time. So this is the way how value stream map can help to minimize the waste. Let's take another example. Cake procurement value stream. Suppose you want to celebrate your birthday, so you have to go to the bakery shop, select a cake, go to bakery counter, ask them, then again go back to selection of a cake, then make the payment, collect the cake and bring to your place and unpack, slice, and then share it. So this is a typical value stream map is created where the value add times, cake selection is a value adding activity, but waiting for 4 minutes or coming and going and selecting, that is just a wastage. So the bakers, discussing with the bakers 2 minutes, that's value adding. Then the payment 2 minutes is value adding, but you have to wait for 6 minutes to making the payment. And after the payment, again you have to wait for 15 minutes to collect the pack, and then which can be just unpacked in 2 minutes and 5 minutes. Again you have to wait, and finally the cake can be used. So the total cycle time, value add plus non-value add, is 42 minutes. Whereas the value add time is only 12 minutes, which is essential. So the process cycle efficiency is 29%. It means 71% non-value add time. Things are reorganized. So this 71% time can be reduced significantly. This is the purpose of value stream mapping. So what are the steps generally required to map the value stream? First, you have to select a product or product family, which is known as a pilot value stream. Because once you are doing a mapping, it's not done for all the operations, all the product family. You select one product family, make a simple process map, and then select it as a pilot value stream. Then form a cross-functional team for value stream mapping. Value stream mapping is not just one man's activity. Here, the people from operation, quality, maintenance, marketing, services, all has to be involved because it has to be seen from all the angles. So a cross-functional team is required. Then collect basic information of process and operational data. According to requirement of the operations, means we have to select which are the lean metrics applicable for specific process, and all related operational data need to be collected before doing a mapping. Follow the process and its information flow. So for the mapping, you have to start right from the beginning, the way material moves in your plant to from entry point till it reaches in the hands of customer or till it leaves the premises of your company. Door to door mapping means one has to follow the process and how the information are being communicated, begin and end with the customer. So how did the product get to the customer? What steps are required? So add matrix and observations. Draw current state means after collecting all the observations and all the measurements, then draw a current state value stream map we'll be discussing step by step. Then once the value stream map is made based on the actual data collected from the operations, then this is analyzed by a group of experts who are understanding all the process maintenance, all aspect of the process, and try to identify where are the gaps, where are the problems created, where are the waste are generated. Based on that, the data analysis and observations, the problems are identified which are resulting to the generation of waste. Then the same group applying the lean tools, they find out a solution, what solutions can be made to eliminate those problems. Based on that, once the problem are solved, then how the value stream will look like, as you have seen in the process of a paper stapling. Earlier it was having a 5-step process, and operations were carried out at 20 feet distance, and the layout change was made and everything was redesigned. So a future state map has to be developed after solving the problems. Then once the future state map is developed, then what problems need to be addressed during next 6 to 12 months to eliminate all the waste being generated. So accordingly, a value stream improvement plan is made. It is a means, in fact, we call it a blueprint for the process improvement. That is made, and this is the ultimate outcome of value stream map, which has to be implemented to solve all the problems. That is the second phase of the improvement journey. So production value stream, typically we examine the value stream in a plant from raw material to finished product. In every plant in this, whether it is small or medium, the material enters, there is a material entry gate and there is a shipping exit gate. Means between the entry to shipping, means door to door, all activities are mapped parallelly, like typically stamping process, machining process, assembly process, and most of the engineering industry is being done from raw material to finished product, the whole thing horizontally. That is called as a value stream. So how does a value stream map look like? It is a visual representation of every process in the material and information flow of a product from customer to supplier end. As you see, the map comes like this one. The whole team develops a map, value stream map in this particular process, where the special icons are used. Just like in any engineering drawing, universal language is used. Whether it is being made in India, the drawing is made in India or Bangladesh or USA or Japan, everywhere the same symbols are used the same way. Value stream map uses a structured, standardized symbol so that it can be created and easily interpreted by all the professionals. So, two main things which are observed in the value stream map: how the information flows. Information flow begins from the customer end to the supplier end, and how the material flows. It is from the entry point of a production plant to discharge, shipping end of any production plant. So this is a closed loop cycle. This way, value stream map gives. How it is done means earlier it used to be done on the A3 paper by the manually. Nowadays the whole team is involved, and the easier way is that post-it slips are used where people are collecting and filling up a data to create a value stream map. So these are the three main documents which are generated in the value stream mapping. Is first is the current state value stream map as is condition, how your process is operating. Once that is a current state map is made, then that is analyzed, problems identified, and it is visualized after the solving the problem, how the value stream map would look like in the future state. That is called a future state value stream map. And to attain the future state, we have to take several problem solving projects to eliminate the problems, to solve the problems, to eliminate the waste. So a plan is made. So these are the three outcomes of the value stream map. Now let's learn how to actually do the value stream map. I'm taking a real case study of a global engineering company. Let's first understand the background of that company. So, Global Engineering Company is a producer of fuel tank bracket for Indian car company. The customer requires 630 brackets per day to be delivered in two lots of 315 brackets each at 12 o'clock and 4 p.m. sharp. Here, the Global Engineering Company is not able to deliver full quantity and desired quality to the customer, resulting to problems on assembly line. The customer has warned the company that if quality and on-time delivery is not improved during 6 months, it will be not possible for them to continue business with the GECO, the Global Engineering Company. In this company, production process involves 5 main processes: stamping, welding, punching, grinding, and assembly, which is managed by 6 operators. To solve the productivity and quality problems, CEO of GECO decided to implement lean manufacturing techniques in its production value stream and hired a lean consultant. The lean consultant, after studying the process, decided to conduct value stream mapping of the process to detect problems resulting to the poor productivity and poor quality. So the very first step, what a lean consultant will do, or any company they want to do, they have to go for the value stream mapping to diagnose actually where are the problems which need to be addressed. Then after that, consultant, as a first step, form a value stream mapping team. Just formed a team to conduct value stream mapping of the process. Following members were included in the team. First, the lean consultant was the coach, guiding the team to map the value stream. Then the production manager or the production engineer, he becomes a team leader because he is operating all the processes. Then quality manager, maintenance manager, materials manager, sales manager, cost accountant, because all these are involved in the value stream mapping. They have to find out the health of the machines, supply of the materials, inventory level of the machine, sales managers, because they have to identify what are the customer needs and what are the pain points of the customers, and ultimately the cost accountant, he or she has to find out how much each operation is costing and how much potential is there to minimize the cost. So a cross-functional team, even sometimes the customer can be also added. So a cross-functional team is made for the value stream mapping. Then the next is just make a simple process. I am sure that everybody is aware about the process mapping. So here simple how the material moves is stamping, welding, punching, grinding, assembly, and shipping. These are the process map. Here the customer requirement is 630 brackets per day. Delivery schedule, first lot at 12:00 hours, second lot at 16:00 hours. This is the simple process map of that. Now all the basic data about the process is collected. So what are the essential thing? First is what is the demand rate, customer demand. 630 brackets delivered in two lots at 12 o'clock and 4 p.m. Then what are the problems faced by the company? On time delivery in full is 0%. Means, of course, they are supplying the material, but in several lots. Then delivered quality, after the delivery, 5% because of the defects recognized during the use of the components. They find that 5% is being returned to the general engineering company, and production cost is 15% higher than the competitors. So these are the three main problems with the company. On-time delivery is nil, delivered quality 5%. In spite of a lot of inspection within the company, it is being returned and the production cost is high. So plant operation 6 days, weeks, 8 hours per day means one shift operation. Net available time for production is 7 hours per day. Throughput yield is 71.5%. These are the actual data collected and compiled. Then plant problems. These are the various kinds of waste are getting generated. Delays is missed because of the waiting waste, defectives which need to be reworked, long changeover time, frequent breakdowns of the machine, customer returns, lot of inspection is required. Inventory data is collected. There's inside the plant there is 41 days material is required, means sitting inside the plant 18 days raw material and the work in process 23 days. Then the processes stamping, welding, punching, grind, assembly and shipping. 6 operators are managing. Raw material is steel sheets delivered twice a month by Bharat Steel Company, who is the supplier, and it is delivered in 15 days lot, and safety stock is maintained for 3 days. So all this information is collected before creating the value stream map of the company. Now comes some data which has to be generated immediately, means just fresh data is required, which has to be measured on the shop floor. It cannot be historical data. Like the 5 operations, stamping, welding, punching, grinding, which are the lean metrics. We discussed it. First is the biggest problem in any process. There is a lot of inventory is involved. Why inventory is generated? Because of the imbalance process and the frequent breakdowns and a lot of problems within the company. So the stamping, there is inventory of 18 days. Welding unit 12,600, punching 250, grinding 635, assembly 955. You see a lot of variation in the inventory at various stages. Why this is happening? Because of the change in the production, because of different production rate, which is calculated from the cycle time. It has to be calculated by the stopwatch, how long each product spends in each process is taken out. Means for cycle time for stamping is 12 seconds, welding 42 seconds, punching 20 seconds, grinding 22 seconds, and assembly is 45 seconds. So there is again we are seeing a lot of variation, which is resulting to inventory. Then the changeover times, wherever the changes, either die has to be changed or the tool has to be changed, or some changes required in the machine from one dimension to another or one product specification to another. So how much time is spent every day in the stamping machine, because frequent die need to change. It requires 2 hours for each changeover. Welding 35 minutes, punching changeover time is 10 minutes, grinding changeover is 10 minutes, and assembly changeover time is 30 minutes. Because for the changeover, a lot of tools, dies, jigs, and fixtures need to be changed, and machine has to be reset. So this is the time collected. This is a fresh time by the observation of the operations with the stopwatch. These times need to be collected. Then uptime is the equipment performance. We find in different operations somewhere 98%, 85%, 99%, 98%. So again it is changing based on the machine condition and machine breakdowns. The first pass yield in each operation is collected. This is 99% in stamping, 90% in the welding, punching 96%, grinding 88%, and assembly 95%. Again, if you see, a lot of variation is there in the first pass. So these are the areas of the concern. Once all this data is collected, now we have to develop a current state map in a structured format. So for all this, for developing current state map, we are going to use, these are the standard symbols or icons used for the current state mapping. Like just like a factory, it is external organization. It can be supplier or the customer. These are the process boxes are used. Then the all data boxes are used to fill up the information. Then the inventory is shown as a triangle, work in the process. In box, how much is there? Then the material received, there the information flow is indicated with the arrows. Electronic information is with a zigzag, that is shown. Operator's phone is with a unique symbol, and go and see the schedule means which need to be inspected and physically has to be seen, like aspects is seen. The movement, how the machine, how the material is moved either by truck or maybe the ship or the aeroplane, whatever the method, this is a truck symbol. And finally, all the timeline is minutes, hours. This is put in a typical type of lines in this particular manner. So after collecting all this data, understanding the symbols, taking the training, the very first thing what a value stream mapping team should make, the very first step, customer information, it has to start in the reverse direction. Starting point for the value stream mapping is the right from the customer end till it comes to the reverse direction. It starts with the shipping, the processing, then the supplier of the material. So first thing is to be made. Indian car company, we are using the symbol Indian car company as the customer, and demand of the customer is put 315 brackets units per day, twice per day. This is the first icon we have used in the value stream mapping. Then comes the second, next step is draw process boxes. There are 5 production operations and 1 shipping operation are there. So the 6 process boxes are made as stamping, welding, punching, grinding, assembly, and shipping. And in each box, 1 operator is indicated. It is managed by 1 operator. So there are total 6 operators are involved to operate these 6 operations. So production process involves 5 main process: stamping, welding, punching, grinding, assembly, managed by 6 operators, means including the shipping. So out of the first, customer information is put, the second, the process box is made, then third comes the data box. Whatever the data collected here for each process, here the CT stands for cycle time, changeover time, uptime, first pass yield. These are the 4 main data relevant to this process. For each process, whatever the data we have collected, actual data, it is put in the data boxes. Then data boxes giving the current state of operations, one can know how long it takes for one product to produce in each process. Then next comes inventory data. Here the inventory is indicated in a triangle with eye inside, means actually physically the data need to be collected, how many pieces are lying in between each operations. This is a physical verification, at any moment has to be done because it may change, but doesn't matter. When you are doing a current state map, at the time of mapping, whatever the actual inventory lying on the shop floor at different stages that need to be counted and collected to give the exact inventory status in the company. Then the next is collect the supplier data. Now we have made process boxes, inventory, all this data, and then comes the reverse side. Ultimately, steel comes from the supplier. It comes twice a month by a truck. So all this data, now the information is starting from the customer end, it goes to the production planning and material resource planning. Here the arrows indicating it is means electronic transfer is there, means it means through the email the information is passed on the customer. So this way the information is coming from reverse side, from the customer side, and material is moving towards the customer. So after making this complete cycle, all the data is put here. Now the most important part is the timeline, how long each material is taking place. So the 18 days, if you see that the timeline, the material there is in the stores 18 days raw material or the steel strips is lying. But whereas the stamping, it spends just 12 seconds to produce one product. Then after that, so many stamped items, 12,600 lying between the welding. These are waiting for the next operation. So this is equivalent to 20 days production that is just lying between the stamping and welding. Then comes the welding. Total welding time is just 42 seconds. After the welding product is the semi-finished, WIP is sent to the next operation, punching days, where 250 items are waiting. It means half a day production is just lying there, inventory is there. Then the punching takes 20 seconds, and after the punching, the material is 635 inventory, 635 units are waiting for the grinding operation. So it is equivalent to 1 day operation. Then grinding cycle time, actual cycle time is 22 seconds where the processing is done. Then after that, material is sent and to assembly where it is waiting for 1.5 days. So assembly takes 45 seconds only. In this way, after the material is processed, it goes for the shipping. Yeah. If you are having any question, you can type on your computer and I can explain. So all the lead time data is calculated and presented in this way. So that now we are going to map how the information flows right from the customer to the production various operations. Like customer information already we have indicated, it comes to production planning and material resource planning. They pass on information to the supplier. At the same time, production planning department makes schedule for each operation, and which is shown in the arrow. There is a weekly schedule is made and it is sent to the each operation and they produce according to that. They follow blindly the production plan, production schedule made by the production planning department. And finally, after collecting all information, then current state value stream map is developed, which gives the total picture of operation. If you see from where the instruction is coming about the material from the customer end, then how the order is placed to the supplier for supply of the material, then the production planning decides what should be the weekly production and shipment schedule. All the schedules are made and the actual condition, actual operating time and the lean measurements are put for each process. If you just see, this is a complete value stream map. It shows that lead time, total lead time for the production is 41 days, whereas the processing time or cycle time is just 141 seconds. This reveals the actual condition of operation. If you just see hardly the material is in contact of various processes less than 3 minutes, but the total time is spent by the material right from the entry gate to dispatch or shipping gate is 41 days. This is itself revealing how much money is blocked because of the heavy inventory. Because 41 days inventory, it means the more working capital is required. More working capital means more interest involved, bank interest involved, and immediately that adds to the cost. So this is showing that how much discrepancy is there. Actual processing time is practically negligible, just less than 3 minutes, but whole time is spent by the complete batch of material is 41 days. This itself reveals that because of the lot of waste, material has to wait for 41 days. Now, this map need to be analyzed why this is happening and where are the opportunities for improvements. So this requires knowledge of value stream mapping, knowledge of problem solving tools, knowledge of various lean tools, and most important, complete thorough knowledge of production process. Here, all the production people, those who are operating the plant, those who are managing plant, they can learn value stream mapping to identify the real problems, and dramatically they can improve the performance of their process by understanding this powerful tool. Now we have made the current state map, just like I gave the example. If somebody is sick, first he has to go to the series of tests, pathological tests. After the report comes generated, that report goes to the physician for the analysis and solving the problem, prescribing the medicine. The same way, after collecting all the data, current state map is made, which shows what are the problems occurring and how much time it is taking. This requires analysis. Now let's see. Purpose of the analysis is gap, the current state where we are now and the future state where we want to. Our processes are in a chaotic manner that need to be improved. What will be the visual picture of improved process? That is a future state map. So here it is a gap analysis to determine the steps needed to get to the desired future state. This is the very first and most important activity for any organization. But unfortunately, because of lack of knowledge and awareness of value stream mapping, people just go on improving the process based on their impulses, based on their own experiences, and that actually doesn't give the desired results. So value stream mapping identifies the gap. Let's see how to go for it. This is a unique and the most powerful parameter, the takt time, that has to be calculated. This is only used in the lean measurements, not in any other production methodology. Takt is basically a German word. So takt time is the available working time per day divided by the customer demand rate per day. In fact, the whole thing is now converted to the time dimension. Example is that in a company, 8 hours available time is, if you see, it is 27,600 seconds. Out of 8 hours, the actual time is this much, where the machine is available for operation. And if 460 pieces are required every day, then what is takt time, demand rate 60 seconds. It means every 60 seconds, one unit of product, finished product must come out from the process. This is the requirement of the current requirement of market. Why it is calculated? Because once we know that this is our order customer wants every 60 seconds one product. So we have to see that whether our all processes are able to produce one item within 60 seconds or not. How the takt time is calculated here, again coming back. One shift operation in the GQ and this company, it means for 480 minutes, lunch break is 30 minutes, two tea breaks in the forenoon and afternoon, 20 minutes, production meeting where the production stopped, all the operators come to the supervisor and discuss, 5 minutes, changeover time is 5 minutes, net available time after reducing all these interruptions, 420 minutes, and demand rate is 60-30 brackets per day. So 420 minutes into 60 seconds divided by 60-30 pieces per day, it means the demand rate is 40 seconds. This way the takt time is calculated. Now we are having the current state map. This requires the lean knowledge to identify the problems. Means where the solution has to be what. So this is all starts with the yellow. They are called the Kaizen burst. Means here the improvement is required. That's why it is called Kaizen burst in the language of value stream mapping. So with the knowledge of process, with the knowledge of lean, with the knowledge of value stream mapping, the team identifies what need to be addressed. Because if you see one must miss information management, there a lot of weekly schedules are there. So each process is producing as per the weekly schedule, irrespective of whether the next process requires or not. And this is resulting to the lot of inventory piling up. So first, if you see the information flow means the production scheduling sequence has to be totally different as per the lean requirement, which has got a opportunity. Here the Bharat strip, twice a month, the material is being received twice a month. So every lot has to be for 15 days, there is opportunity. It can be reduced to once a week. So automatically the working capital inventory can come down. These are the items. If you see now, the processes are made in two different blocks where the potential for combining it, welding, punching, grinding, they can be combined. They can be joined together without any gap. But for that you have to improve the cycle time of all the operations, then only it is possible. So these are the problem area like a stamping operation, changeover time 120 minutes. Those who have heard about SMED, SMED is one of the operations, single minute exchange of die, which says that any die has a potential to be changed within less than 10 minutes. So, but here 120 minutes is the company people, they learn the SMED technique, they can significantly bring down the changeover time. So this is one Kaizen bust. Here in the welding, you are seeing that 42 seconds is very long cycle time for the welding, which can be brought down. Then the uptime of 85%, it means there is a frequent breakdown is taking place in the machines, which has to be improved. Then the first pass is 90%, it means 10% defects are getting generated. This need to be looked. So these are the several Kaizen bust means these are the opportunities for the improvement in the company to improve the process. So once all these things are analyzed, as I told, with the knowledge of process, with the knowledge of lean tools and techniques, one can find out these are the improvement opportunities. So this becomes projects for the improvement, or these are the problems which are the projects for the improvements. By study of current state map, one can identify these are the problems existing in the company which can be visually seen just after making the value stream map. If there is no data put in this way, nobody can find out where are the problems. Now, with the factual data and putting all these things, one can see the imbalances in the operations and identify the opportunities for improvement. That is a Kaizen bust which must be addressed to make the process effective. Now the same thing, this is a very powerful technique, just putting these things, all the operations, if you just see the bar graph of cycle time of these things and draw a line of takt time which is 40 seconds. Now if your cycle time is more than the takt time, it means that your production rate is lower than the demand rate. If it is less than that, it means your production rate is much higher than the demand rate. If you are continuously producing with the low cycle time, you are piling up inventory. But at the same time, if your cycle time is more, then it means that you are not able to meet the requirement of the customer. So whatever goes above the takt time, that has to be brought below cycle time, has to be brought below the takt time level. How you can do it? By making Kaizen, by making improvement in the process, improvement in the operation, improvement in the technology. So this gives the clear idea that where the cycle time has to be reduced, and other operations where cycle time is less, it means there is no need for 24-hour operation. Even the one operator can handle the two processes, half a time this one and half time another process, without impacting the productivity of entire process value stream. Let's see. By seeing all these things, it means that two circles are made. Stamping, if it is cycle time is less, it's a very fast process. And most of you must have seen very fast. The stamping press, they operate very fast. Their production rate is there. So it's very difficult to synchronize. It has to be separated, independent process. And the other operations, welding, punching, deburring, assembly, all these has to be put together in a synchronized manner. So two phases we have made here. Now based on the study of the Kaizen bust, what are the problems identified? First, changeover time high, 120 minutes in the process of stamping. What action is to be done? It has to be reduced. Welding cycle time is very high, 42 seconds. Equipment dying time high is 15%. Defect rate is high, 10%. So all these need to be reduced. In the grinding, defect rate at grinding high is at 12%. Assembly cycle time is 45 seconds, very high. Changeover time is 30 minutes. It has to be reduced. Defect rate assembly high, 5%. It has to be reduced. So purchasing frequency twice a month. It means that to reduce the inventory, you have to increase the frequency maybe 4 times a month, 5 times a month, depending on the other parameters. So this is the outcome of analysis of the current state map. Now you have identified 9 problems which is resulting poor productivity and low quality rate. So these need to be improved. Now let's see how a future state map can be done. If you see the current state map is like this one. The stamping, welding, punching, deburring, assembly, these are the cycle times. Here the stamping, welding, punching, assembly, all cycle time has to be brought down, and by clubbing 2 operations, it means instead of 5 operators used, now you can use the 4 operators and combine the operations so that everything comes under the takt time limit. So this is a future state cycle time. It has been designed, not yet started, but this is a designed, you have designed, these are the possibilities for the improvement. Now let's say what has been done in the future state design, separate the stamping process as standalone operation because that is a very fast process, whereas the other operations, the welding, punching, deburring are the slow operations, different nature. Reduce the cycle time of welding operation by Kaizen. How you can reduce? Applying the Kaizen technique or A3 problem solving technique, that is a Kaizen. Combine the welding, punching, grinding operations on the same workstation by balancing cycle time for all three operations. If you just do combine, so all the inventory in between these operations is totally eliminated. Reduce the cycle time of assembly by Kaizen. Again, make some improvement in the process by A3 problem solving methodology. Then implement supermarket and Kanban system, reduce lead time. The supermarket and Kanban are the unique tool which are applied to reduce the inventory between the two fast and slow process. So let's see again for the future state icons, just like in the current state map, we are using typical map icons, symbols. The same way future state icons also use the symbol. Here if you see like a rack system, a supermarket is used, just like you see in the supermarket. If you want to buy a t-shirt, you go to that area, you will find the several sizes and several colors are organized in the racks in the supermarket. In fact, the Taichi Ono, the inventor, and Kichiro Toyoda, the managing director of the company, once they were visiting in USA, they just accidentally went a supermarket mall and they got that idea of supermarket, how we can control the inventory. And the same, that's why the same symbol is, similar symbol is used and same name is given. This is the methodology being used to control the inventory. Here the Kanban system, that is a withdrawal, means it has to be pulled back like this one. Kanban arriving in batches, cards are used, that is a signal. So these are the various kind of signals icons are used while making the future state map. The same process now, after analyzing the current state map and finding the solutions, it was observed that the whole, instead of 5 operations, it can be 5 work desks, 5 independent processes, it can be done in 2 processes. One, stamping is a fast process, a supermarket is created, which is a much faster, means almost 4 times faster, means what the welding, punching, grinding operation will produce in 8 hours, that stamping operation can produce the same thing in 1 hour, means the same requirement in 1 hour. So instead of just running stamping all the 8 hours, it is just operated for 2 hours and fill up with the supermarket box, because that's good enough for welding, punching and grinding operation. And this way the whole thing is kept here, and the operator, after operating 2 hours of the stamping operation, he is being utilized at some other place. So this way 2 work desks has been created. This is the future state map is made. So instead of 3 separate work desks, if you see welding, punching, grinding, by improving their cycle time to 40 seconds by using the Kaizen, so all 3 are combined together. So between the welding, punching and grinding, there is no inventory involved, and this is combined at one place and all operations are made here, and the supermarket is created, so that without interruption of the production, enough stock is maintained. At the same time, inventory is drastically reduced. As long as supermarket is full, the previous process need not operate. Once it is empty, then they have to start refilling. Just like in our water tank in our house, when water tank level comes down to safety level, then automatically valve opens and fills up. Once it is full, the automatically valve closes the further supply of the material. Again, when the level comes down, again automatically supply is done. Pump operates. Exactly the same way the supermarket system works. Some material is stored. Once the material level comes to alarming level, then again the production starts. So the circle pull, it means that is a pull is created whenever the material is required. So the future state is redesigned in this way. And if you see the lead time, which was total 41 days, it has been brought to 13 days, whereas the processing time or the total cycle time almost same. Here the main purpose is that to reduce the lead time. How it has been done, if you see the welding, punching, grinding, all cycle time has been brought to 40 seconds. It means the rate of production of all these are equal. If it is all equal rate, then there won't be any inventory. Where the stamping operation, just it is separated, it has to be operated only 2 hours, whereas other operations can continue for 8 hours. And the operator, stamping operator, after 2 hours of production, he can go and work at some other place. So this way, a new future state map is created, and now it has to be realized after making improvements in the process. Another significant thing you can notice in the current state map, production planning, they are giving production plan for every week to all the processes. So irrespective of the requirement, all the operations they are producing as per the weekly production plan, whether it is required or not. Now here the information flow is totally changed. Only the shipping, they know how much they have to ship every day, and based on that they create a demand pull from the previous process that decides, and which is separated by supermarkets. So this way the future state map helps in the reduction of inventory, and all the production planning, whole methodology is changed. Only means now the shipping will decide how much will be produced every day. So here the stamping pull supermarket is created. This is called as a Kanban system, just-in-time system. So from application of these new tools, from 41 days to 13 days inventory has come down. So now these are the two things are made, current state map, value stream, and the future state map. Now the next is you have to set the target. What are the key lean metrics? Lead time, process time, inventory, quality, production, delivery, on time in full, and manpower. All these metrics, current state was 41 days, lead time, process time 141 seconds, inventory 25,830 pieces. First pass yield was 71.5%, production 532 units per day, delivery was on time full, it was being delivered but in various batches, 0%, manpower 6. Now the future state target, now based on the actual operation and potential, it is said that it has to be brought down to 13 days, process time 132 seconds, inventory 8190, quality 92%, production 630 units per day, delivery on time in full 100%, and manpower 5. So improvement targets were set, and the reduction in, just see, dramatic reduction is possible. 68% reduction in the lead time, 6% reduction in the process total cycle time, inventory reduced by 68%, quality first pass yield improved by 28%, production 18%, delivery on time made 100%, and manpower reduced 16.66%. So these were the targets set, and then the improvement plan is made. How the improvement plan? Now, based on the priorities, which are the more critical, here the Pareto analysis can be used to prioritize the projects. So these 9 projects were identified by the value stream team, which need to be addressed by A3 problem solving technique. This becomes 9 projects which need to be addressed through problem solving technique, where the A3 problem solving or Six Sigma DMAC problem solving, there are many techniques are there, so they can be solved. And 1 year schedule is for 12-month schedule is made for that. Here the current staff, the operation production, they have to devote at least 20% of their time for the continuous improvement process. So that's why it is staggered, means the main operation should continue at the same time. They must spend at least 20% for improving the process. So based on that, means a schedule is made, the project by project it has to be done. All cannot be taken together because then the normal production would suffer. So the first project reduce assembly cycle time. So here the 3 months time is taken. It's generally 90 to 100 days. The project should be completed less than that. So that is for each project a different team is made. They have to learn the A3 problem solving technique and work under the guidance of some lean expert. Then the second project, improve assembly first pass yield. Here again this can go together. So this is requires 3 months. The reduced welding cycle time. After these 2 projects are completed, the same team or the other team can work for another 3 months. At the same time, parallelly improve welding first pass yield, because all the different people are there, cross-functional teams are there, operators are involved. So this way, each project like improve welding first pass yield, improve welding uptime, reduce assembly changeover time, reduce welding changeover time, improve grinding first pass yield, introduce just-in-time and Kanban system. So before doing this project, all the project team members need to be trained on the applicable tools. This requires a lot of effort, a lot of time to learn that one and implement that technique during these 3-4 months to improve the projects. Here, the lean approach says that here the training is 20%, doing is 80%. So this is called as learning by doing approach. This is learning by doing approach, and this way, under the guidance of a lean coach, they learn it, they apply it. In this way, they learn, and the process improvement takes place. So this is the main outcome of the value stream map process outcome, and this is just like a treatment prescription given by medical expert, physician, after conducting all the tests, all the diagnostic tests and studying the reports, he identifies what need to be done by the diseased person to improve his or her health. Exactly the same way, after collecting all data, capturing the current state of operation, understanding the improvement opportunity in the process, and identifying the problem areas, a improvement plan is made, and this is the basis for continuous improvement of the entire process. Currently, what being done by the company, wherever the problem comes, they just pick up the problem and solve it. That problem may be solved, but the whole entire throughput is not impacted because it is not being holistically addressed. That's why isolated problem solving doesn't help the companies to improve the overall performance of the process. So the value stream mapping, I recommend this is a most essential and the must activity to diagnose the problems in a structured way and develop a proper roadmap for improvement. So what is the next is to implement the plan. How to implement the plan? Next phase of the value stream activities. We have identified these are the 9 projects. All projects are to solve the problem related to quality, related to productivity, related to equipment availability, related to process velocity, related to inventory. All these 9 problems need to be solved. How to solve it? If you see, the whole philosophy of lean is the continuous improvement. Improvement journey will never stop. Just like athletes, we are seeing in every Olympic, even the gold medalist, every time they are trying to improve their records. How they do it? By continuously improving their practice, identifying the weak points in their methodology. The same thing is applicable. This is the current state we are here. Through the value stream map, we have identified what is the gap between our desired state. And then by learning the tools and applying the problem solving technique, next phase, A3 thinking, through the PDCA approach, that is 8-step PDCA approach. So we go on raising the performance of process step by step, which can be continuously improved, and next future state means there is an ideal state. In fact, there is no specific target for ideal state exact. So brick by brick, year by year, using the problem, the value stream mapping and learning the problem solving technique, A3 process thinking, we continue to improve our process to create a benchmark to increase our production, productivity, quality, competitiveness, sales volume, and profitability. This is the only way any process, and these techniques are applicable to every manufacturing or the service unit, whether the process is small or big, but the approach is same. So this is the unique technique, and these are the methodology, proven, validated methodology, which is already seen and learned by so many people at the Toyota. I had also opportunity to see the production process of Toyota, take the training. So they are continuously improving using these two, the most important and the most powerful tools of the value stream mapping and the A3 problem solving. So to attain the goal of organization, we have to continuously improve, and the very first step is that you have to conduct a value stream mapping, identify the problem, and then give a focused approach to solve every problem project by project, and using the various lean tools and lean methodology. So this is an overview. Of course, it requires minimum 3 to 5 days to conduct value stream mapping of any specific value stream, where all the people involved, all the process owners are involved, those who are operating, so that it becomes easier to collect the data. So detailed examination of each process data collection is required. So this is a small overview I tried to give you to understand the methodology and the importance of value stream mapping to make your process world class by applying the various lean tools. So now what to be done after the value stream improvement plan is made is the A3 problem solving. That I'll be covering with an actual example of one what I have applied in one of the small and medium industries during lean implementation that I'll be discussing on the 15th February. So this is about the value stream mapping. Yeah, I couldn't get any question. If you are having any question, you can still type here, or you can email to the eCafes. I'll be glad to respond to your question.